everyone. So this is the fifth numerical from tension member. So before solving this numerical, I will recommend you to go through the previous lecture notes and the video lectures because every concept will be required to understand this topic or this numerical. So the question is, determine the tensile capacity of the section shown in figure 6.4 if angles are placed on the opposite sides of gusset plate within bracket tag bolted, angles are placed on the same side of gusset plate within bracket tag bolted, angles are not tag bolted. So let us look at the figure. So this is the figure A and this is the figure B. So this is the question A actually and this question B. Okay, so you have to find the tensile capacity. So here from this figure you can understand that two angle sections are placed, one on the left of this gusset plate, okay, and another on the right side of the gusset plate. These angle sections are 90, 60 into 8 millimeter, and there are 6 number of bolts which are 16 millimeter diameter, okay, and the longer leg is connected. So this is 90 millimeter, this is 60 millimeter, 90, 60. Here also in this figure 90, 60. So the both in both the figure angles are same and the number of bolts and the diameter are same. Okay. Also from the this edge to the bolt, this is 30 millimeter. That means in the longer leg, okay, from this root, okay, to this bolt, this should be 90 minus 30. That means 60 millimeter. Here also, if this is 30, so this should be 60 millimeter. Okay, from this root to this bolt, center of the bolt. Okay, and if you see from right to left, okay, in this direction, so right to left, then okay, what you will see? You will see this figure, and this is the inverted figure actually. Okay, if you take only one angle, so this is the figure with one angle, so you will be watching from right to left, okay, inverting this angle, then you will see this figure. So there are 6 number of bolts, okay, and this is the edge, outer edge, this is the root, okay, that means this is the base of the shorter leg. So here it will be this line, so from this line to this line it should be 90 and it should be 30 as given here. So this is 30, that means this is 30 here. Okay, I hope the picture is clear to you. If you don't understand, then rewind these video lectures to get a clear idea. Okay, now so for these two figures we have to find the tensile capacity of the section, okay. So here in this question you should know what is tag bolted. So tag bolted means tag bolting are the bolting when we will be providing extra bolts to maintain the pitch actually. That means here in this figure there are 6 bolts. It may be required that to maintain the pitch, okay, there is a minimum pitch and maximum pitch, so some bolts may be required to maintain that criteria. So that those bolts will not provide any strength and will not be considered in calculating the strength, so that is tag bolting. Okay, so it is not our concern about the tag bolting. Okay, so before we start this solution, let us go to the IS 800. Then so this is IS 800. So here in section 6, that means in page number 32, we should go through this part. Here tension capacity means tension strength, tensile strength due to yielding of gross section. You should find this answer for this question. Okay, then you should find this design strength due to rupture of critical section. Okay, within this heading, this formula is for the plate. Okay, so design strength due to rupture of critical section. So you have to find this strength for angle. Okay, so let us go to the angle. So single angles. Okay, there is no heading for double angles. That means you have to multiply the strength if there are two angles. Okay, so the rupture strength of an angle connected through one leg is affected by shear lag. I have explained this in lectures. Okay, the design strength TDN as governed by the rupture at net section is given by this. TDN is equal to by this formula. Okay, now here some constants are given, or the factors are given. So the beta, so beta is given by this equation. Okay, so in this equation you should know what is this W and what is T. T you know, Fy, Fu, Bs, Lc. Okay, so the value of beta will be this. Okay, so it should be less than equal to this value, and this value should be greater than equal to 0.7. Now what is W? So W is the outstand leg width. Okay, so that means this one. So in this figure, this leg is connected and this leg is not connected. So this is the W actually, outstanding leg. Okay, so this is W. Then BS, shear lag width, as shown in the figure 6. That means BS is equal to this, it is highlighted. BS is equal to W plus this W T, or W, or maybe minus T. Okay, that means this, what is this? So from this root of the angle to the center of the bolt. Okay, then minus T. So this is the BS. So in this equation, W, T, BS is explained. Now what is LC? LC, length of the end connection, that is the distance between the outermost bolts in the end joint measured along the load direction, or length of the weld along the load direction. That means basically it is the length of the connection. Okay, so in this figure, if you see this figure, so what is the length of connection? Outermost, what is the length of two outermost bolts? That means from this bolt, okay, from this bolt to this bolt, okay, this bolt to this bolt. Okay, so that should be 40 plus 40 plus 40 plus 40 plus 40. That means 5 into 40. Okay, now let us go back to the IS code. Then this for other section, that means other section for net critical section, that means this one, design strength due to rupture of critical section. So we need the only angle section for this question. So we have explained this. We know this, what, how to find out this TDN. Okay, now design strength due to block shear. So you have to find this also for this angle section. So in my previous lecture I have explained how to find out the block shear. So there is two equations, as I have already explained. Block shear means a block will be tearing out. So in tearing out action, then one plane will be subjected to shear force, and another plane which will be perpendicular to the shear plane, that will be subjected to tension. Okay, so there is two formula, and you have to find this block shear strength by these two formula, and lesser one will be the block shear strength of the section. Okay, so everything is explained in my previous video lecture. Okay, so this is up to the uh, tension member. So let us go back to the question. So here first point is we have to find the gross tensile design tensile strength due to gross section yielding. Okay, that means this one. Okay, so the formula is this. That means let us go back to the formula here. That is TDG is equal to AG into Fy by gamma m0. So like this, TDG equal to AG into Fy by gamma m0. So AG is this, Fy is this 250, and gamma m0 for yield strength is equal to 1.10 into 10 to the power minus 3, that is to convert into kilonewton. Now in this part, what is AG? AG is the gross area, and how to find this? So if you open your steel table or SP6, okay, then for this angle section, that means this ISA 90 cross 60 cross 8, this cross sectional area or gross section area will be given. Okay, so I have this steel table, so let us go to this steel table. So if you see this steel table, so this will be the first page and it will be supplied in your exam. Okay, so if you go to the contents, so you can see the properties of two unequal angles back to back, longer leg connected. Okay, now here the angle is ISA 90 cross 60, that means leg size are 90 and 60, that means unequal angles. Okay, and it is provided on back to back, so that means the angles are provided on the two sides of the gusset plate, and there is no formulas or no values for the condition when the angles will be placed on the same side. So that means the value will be same for the two cases, two figures here. Okay, so you have to go to the page number 22. Okay, so 22, page number 22, you can see the heading. Uh, you should be using this steel table, because if you use this steel table for the first time in your exam, then you will face lot of problems. So you should be habituated to use this code. Page number 22. So 21, 21, 22, properties of two unequal angles back to back, that means this is the figure. Okay, arrangement. Here I have to look for ISA 90 cross 60 into thickness will be 8 millimeter for our question. That means this one. So ISA 90 cross 60 cross 8. So this one, no? So this one. Okay, so this page will be first page and this will be the second page. So all the values is for the means these two pages are connected. Okay, so I need AG, that is, if you look closely, it will be sectional area, that means this is the AG. So it is 22.74 centimeter square. So other values, that means moment of inertia, modulus of section, radius of gyration, everything is given, center of gravity. So whenever you will require these values, you have to take this reference. Okay, that means this steel table. Okay, now so in this figure, this is AG, so 22.74, that means in millimeter square it will be 22.2274 millimeter square. Okay, so um, this will be the answer in kilonewton. So design stress due to net section rupture will be uh, the formula which I have explained, this one. So that means here I have written this, the writer has written this formula. Okay, so what is ANC? What is ANC? So ANC is the, look at this, where net area of the connected leg. Okay, so that means the net area of the connected leg will be, let me just charge this my laptop. Okay, so net area of the connected leg. So here uh, beta is explained, a geo, that is equal to gross area of the outstanding leg. Okay, and t is the thickness of the leg. Now the section is double angle section with long legs connected. There are 6 bolts 16 millimeter diameter at a pitch of 40 millimeter. So we can understand this from the figure. So let us find all the values by one. So this ANC, let us find this first. Okay, so ANC, okay, ANC net area of the connected leg is equal to 2 into, this 2 is for the 2, there are two angles, so 2 into 90, that means connected leg is, this one is the connected leg, this leg is connected leg. Okay, so if I draw a line through this bolt, okay, so 90 minus 1 bolt hole minus thickness by 2. Okay, so as I have explained this in my previous lecture, so 2 for 2 number of angle, then 90 minus 18 minus 8 by 2 is the length multiplied by the thickness here. Okay, that should be this millimeter square. Then gross area of the outstanding leg. So the gross, in the gross area, so what will be this area for this outstanding leg? So it should be 60 minus t by 2 into 8. So 60 minus t by 2 means t is 8, so 8 by 2 into 8, so 896. Okay, 2 into this. So now ANC is found. Okay, then AGO is also found. Then you have to find this beta. So to find the beta we need this BS. So we have to open our IS 800 because beta is given here there. Okay, so to find this beta we need this W, T, BS and LC. So BS is the shear lag width and LC is the length of the connection. Okay, and this W is the outstanding leg width. So length of connection is 5 into 40, that means from first bolt to last bolt 5 into 40, and then W plus W1 minus T. So this W is the outstanding leg width, that means this is 60 and this is 60 because this is 30, so total is 90. So if it is 30, then from this point to this this point. Okay, so this is the uh, W1 actually. So W plus W1 minus T, that means 60 plus 60 plus 60 minus 8, so it will be 112 millimeter. Okay, so next is this. So beta will be 1.4 minus this w by t. So just put the all the values here, so you will get the answer. Okay, so it should be less or equal to fu by fy multiplied by gamma m0 by gamma m1, and it is found in this here. So 410 by 250 into 1.10 by 1.25, it is 1.44. And so here it is told that uh, this, so this beta should be less or equal to this one and should be more or equal to 0.7. Okay, so this should be less or equal to this, so that is they have got 1.205, so it is less or equal to this one, that means this is equal to 1.44. So 1.205 is less than 1.44, and it is also greater than 0.7. So this beta is okay. Otherwise, if it is becoming uh, 1.5, then you should take this 1.44 maximum value. This is the minimum value. Okay, so now, so our beta, we can take this beta. So now then we can find this design strength due to net section rupture. Okay, so use this formula to find the answer. Okay, so it should be 602.24 kilonewton. I hope you can find this. Then next, third is, as I have told, you have to find the block shear. So for block shear strength, uh, so I have corrected this figure actually, because this is 30, so it should be 30. So in case of block shear, this block may tear out. Okay, so, and in this case, tension is applied on this side and on this side. If you apply tension force, okay, because this member is under tension, so tension will be applied on the left and here on the right. Okay, okay, now, so if you write your formula to find the block shear strength, that is the first formula. Okay, and this is the second formula. In this formula, avg, avn, okay, and atn, and atg is required. Okay, now avg, that means if we apply tension force from left to, sorry, right to left in this direction, okay, in this direction, so this will be the shear line and this will be the tension plane. Shear plane, this will be the shear plane, and this will be the tension plane. Okay, so we have to find this gross area of the tension plane, and then net area of the tension, gross area of the shear plane, and net area of the shear plane, and gross area in of tension plane, net area of the tension plane. So four area should be found. Now avg, so in case of avg, it is from this point to center of this bolt. Okay, center of this bolt, if I zoom it, so from this point to center of these bolts, so the distance will be how much? 30 plus 40 plus 40 plus 40 plus 40 plus 40. Okay, so this is the length, and there will be a thickness of the member, so it is 8. So it will be simply 5 into 40 plus 30 and into thickness, so it is 1840 millimeter square. Similarly, for shear net area, so in this line from this point to this point, there are one number of bolt, 1 2 3 4 5 bolts and half bolts here, because the corner point will be at the center of the bolt, so half the diameter should be deducted for this bolt. So 5 plus half, that means 5.5 bolts should be bolt holes should be deducted. Okay, so that means here in this figure 5 into 40. Okay, if I okay just so 1 2 3 4 5 from this center of this bolt to this point. So 5 into 40 plus 30 minus 5.5, 6 minus one, half, that means 5.5 into whole diameter. Okay, within bracket, then it is multiplied by the thickness, so it will be this. Then TG, so from this center of the bolt to this point, this is equal to 30. So in gross you should not deduct this whole, that means 30 into this thickness will be 8, so 30 into 8 in case of gross ATG, and in case of ATN, so 30 minus this half. So the bolt hole, in this bolt hole from this point, okay, from this point actually, from this center, so 30 minus half the diameter, that means this radius, half the diameter should be deducted to find the net length. Okay, and that should be multiplied by the thickness, so you can find the ATN like this. Okay, so ATN will be this, so you can put these values in these equations and you can find the two block shear strength. Out of this the lesser one will be the block shear strength. So there was some mistakes and I have corrected this, but I have not found this answer. Okay, so ATG will be modified, ATN is modified, and so you have to put this ATG and ATN in the proper place, and then you have to find this answer. Okay, this should be changed. Okay, then out of these two values, lesser one would be the block shear strength. So so out of these three strength, that means first one is was the gross section yielding, second one is the net section rupture, and third one is the block shear. So out of these three values, lesser one will be the tensile strength capacity of the this setup. Okay, here in this block shear strength 2 will be multiplied because this formula was used for one angle section, so for two angle section it should be multiplied by 2. I hope you can understand this. Okay, so second question, angles are placed on the same side of the gusset plate. As I have already told you that there is no change for the area or the parameters, so the for this case also the strength will be same. Okay, and for third question, the angles are not tag bolted, that means as I have already told you that tag bolting is done for or to maintain the pitch, or to restrict, or to resist the buckling effect, or to maintain the proper spacing between the gusset plate and the connected angle section. So it does not contribute any strength to the connection. Okay, so it is already omitted. So if we provide the tag bolting and does not provide the tag bolting, the case will be same. So for the three cases strength will be same. Okay, so I hope you have understood this numerical. If you don't understand, I will recommend you to go through this video lecture uh, once more and try to understand again. And even though if you have any doubt, then contact me on Google Classroom or on WhatsApp. Thank you.